Okay, this is it. This is going to be the best video ever. So we have moved to actually chapter 22, the theorem of Pythagoras. Okay, so we're going to be using pen and paper, don't you worry. We're going to be going with your book, and we're going to be going with the log tables, and we're going to be going with your actual book, not just those PowerPoints. Let me open it. Here, higher level. Looking for a very big book. That should be it. One bookmarked, one not, I'm not sure. This one is ready to go. Okay, so cool. Has it got bookmarks? Yes, it does. What chapter was it on? 22. Okay, guys. Pythagoras. So lovely and cool. Okay. Do we want to look at this way? I might use technology, but I can't find it now, and it'll be too slow. So here we go. So before we do anything, so right now I want you to title. Okay, the title of today's class is Pythagoras. Let's write down his name. Pythagoras. But it isn't really just his name. He made a theorem. So we'll start learning about theorems and what makes a theorem. Okay, we need a right angle triangle. Let's draw with the insert of our 30, 60, 90. Let's put it this way. And let's use a pencil. 1, 2, 3. Okay, let's eyeball a square up here. So it should be pretty good. A pretty good square, not a very elongated rectangle, and eyeball 3 squares here. Let's call this A, B, and C, just like it is in your log tables. So we're heading out to trigonometry, actually to page 16, nearly geometry. Okay, and we're drawing this triangle here, but it doesn't have to be slightly slanted. Okay, and according to the log tables, if that's true, if you have a right angle triangle, I'm flicking back to my camera, if you have a right angle triangle, I've just drawn that in for you, then you have this equation that, or let's say you have the big idea that these two squares, let's put B in, let's put B in there, and let's say this guy gets broken up. Basically these two squares have the same area as this square, and the way we write that is that C squared equals A squared plus B squared. Okay, so this formula, Pythagoras' theorem, that says if you have a right angle, if it implies you have this equation, but the implication goes the other way too. And then back to our log tables to see where that is, where this notation is. Where am I producing this crazy symbol? Well, it's in your log tables and it's nice to know it. Now will I go to the just beyond sequences, there's sets and logic, and in sets and logic you have these symbols that you can use mathematically. I know you know how to use plus and equals and all that. Well, these are really cool symbols for theorems and very important. You'll see them in your book. Implies is a one-directional thing, and this is kind of implies both ways. It says it is equivalent to, because it goes both ways, but you can say is implies both ways. Okay, which I've just used. Back to my drawing. I'm short on time now, so it's going to be a short lesson, but basically what we can do is we can take a square root of both sides. Now another little quick thing is this length has to be positive. Distance is positive, and that implies that when we start using this I know I have it in the screen and this looks like it. Oh no, you don't see me now. When we use this formula, these guys could be straight bars. They could be the absolute this again, but they could be the absolute button on your calculator. And for that reason, when we're applying this, we'll be subtracting in either direction. So say you have a 7, 2 and minus 3, 9. Okay, you'll go 9, take away 2, and then you'll add them to 10. And you'll just go square root of 7 squared plus 10 squared. Okay, so look, that's it. The whole idea. I just testing this video. I'll see can I play it in class. Didn't get a whole lot done, but that's not important. It means I'm able to make videos for the future. Okay, I'll pull the plug because I got to get to school. But I'm going to play this for you anyway, and we'll continue on and see could I do the exact same thing in class. Wouldn't that be cool? Okay, see you in the next one.